traffic lights,
traffic signals,
stoplights,
or in generic word, robots.
As we all know, those are signaling devices positioned at road intersections, pedestrian crossings, and other locations to control the flows of traffic.
Short fact, the world's first traffic light was a manually operated gas-lit signal installed in London in December 1868, but it exploded less than a month after it was implemented. Ouch.
But right now, we're not going to talk about that old stuff.
We are going to talk about radar in traffic system.
Yeah, let's get right into it. Despite the traffic light system have not been changed for decades, it is without doubt a system that can be tempered and make it even better.
Also, because of this system haven't been changed for a long time, it is bound to get a little problem. In fact, most pedestrian accidents in built-up area occurs at intersection. Even after signalization, the number of accidents involving pedestrians often remain high. There are a lot of studies and ideas that have been thrown to fix this problem, such as signalization of a high-speed intersection, which means speed above 30 km per hour in at least one arm or even crosswalk should be located less than 2 meters from the intersection to optimize pedestrian safety.
Alas, despite all those studies, it's inevitable that accidents still happening all around the world. The problem should not only focus on the road users like cars, motorcycle, or the placement of the crosswalk. The conflict studies as well as analysis of accident data show that one should examine separately accidents between turning vehicles and green walking, quote-unquote, pedestrians, and accidents involving pedestrian walking against red light. The problem is, in the end, back to the pedestrian themselves. So, from this, we thought I create a system based on the application of sonar or radar on the crosswalk to positively solve the problem between the road users and pedestrians.
This system helps the rushing pedestrian to not blindly run against the red light, as the sonar radar will detect any object that is coming near the sonar and keeping the pedestrian traffic light stays green. With this, the problem from rushing pedestrian can be reduced drastically. The ultrasonic sensor centered on the theory of echolocation. Since the ultrasonic sensor uses sonar to determine the distance to an object, sunlight, spotlight, and surface color of the object that affect the reading of any infrared distance sensor does not affect its activities. However, it can be difficult to detect acoustically soft objects such as clothing. To measure the time difference between the signal that has been transmitted and received, the echo is processed by the control circuit. This time can then be used by the ultrasonic module to measure the distance between the sensor and the reflecting object, send a signal to the object, then receive the echo signal from that object. The basic concept of an ultrasonic sensor consists of two ultrasonic transmitters, which is basically a speaker, a receiver, and a control circuit, and using it non-contact ultrasonic sonar to determine the distance from an object.
With those theories in mind, here is the simulation that we managed to make and simulate. The software I'm using is Proteus Egg Professional, as it is a proprietary software tool suite used primarily for electronic design automation. The software is used mainly by electronic design engineers and technicians to create schematics and electronic prints for manufacturing printed circuit board. So basically, this software is perfect to fulfill the assignment. Here, as you can see, as the button state is high, the servo will start moving. As in the idea, the ultrasonic sensor will be implemented on the servo in order to move it 180 degrees to scan the surrounding. As you can see, on the ultrasonic sensors, that's a test pin, which is it will give out signal whether there's something detected by the ultrasonic sensor. Sorry, whether it was detected within the ultrasonic range, as the light will keep on being green until the button state is low, or there's no object detected anymore within the range. Alright, now I'm going to show the codes. Let's go.
The prophecy is true.
Yeah, just kidding. There's no way the code's gonna be that long. I just did this on CMD. Look at it.
Wow.
Let's get back to it. Here is the Arduino code. As you can see, I only use two libraries, which is ultrasonic.h and servo.h. And in this part, I define the trick and echo pins of the ultrasonic sensor, which is the trick pin at the 10th pin, and the echo pin is at 11th pin. And now this is the number of the push button pin and the LED spin. You can see the button pin is 4, the red pin as the red LED pin is 2, and the green pin, the green LED is 3 at the third pin. For the variable, I use two variables, which is the integer distance and integer button state, which is equal to 0, as is the variable for reading the push button status. And servo, the servo command is to create a servo object for controlling the servo motor. Within the void setup code, we basically just defining which is input, which is the output. In this setup, we can see that button pin and the echo pin is the input, and 3 pin, red pin and green pin as the output. And in the command my servo.attach, that is the number 12 is the pin that is servo connected to. Within the void loop, I first put out the button state equal digital read button pin, which is it will read the state of the push button value. And after that, I use the if else command, which is if the button state is high, it will then move the servo motor from 50 to 165, as in this case I use 170 degrees. And after that, it will move the servo with a delay of 30 milliseconds, and use the detection function. After that, it will repeat again, but in reverse, the same thing, the same process. And after it ends, it will delay for 60 milliseconds. But else, the red pin will be high and the green pin will be low. In this function called detection function, it will read out the measured distance by the ultrasonic sensor and make up from the data which whether it will be the green pin will be high or red pin will be low. And after that, it will return to distance, which back to the void loop, and then it will go back to the process of the void loop again and again and again. And that is it for the codes. For the PCB layout, as you can see, this is our PCB layout, but unfortunately I only managed to find the design pin for Arduino Uno. By design pin, I mean the package tools. As for the ultrasonic sensors, I just can see that I'll be able to make it on my own. You can take a look here what I've seen, what I've saw. So yeah, I don't think I can make the package on my own. I've tried search in the internet also, but alas, I find nothing. But the 3D visualize did look cool though. It did.
In conclusion, the two main objectives of this project, which is to design a pedestrian crossing light prototype to prevent people from rushing across the traffic light when it almost turned red, and to implement all the engineering practice principles that was learned throughout the course, were achieved during this project development period.
And that is it for us. Please like and don't subscribe, because hell, we're not going to make any kind of content for a while. So thank you very much and have a good day. Peace out.